Welcome back to another space gas video tutorial. In the previous video, we defined the steel design data for the right-hand rafter of this model. Let's now repeat the process for the rest of the model. Starting with the curved rafter on the left, we will first select the member at one end, and then select the other members in the rafter. The member that we selected first determines which end of the rafter is its origin. In this case, the knee end. Note that we are not including the cantilever, because the design rules for cantilevers are different to other members, and it must be dealt with separately. Note also that we must not extend a steel member over a major axis support for that member, and that is another reason why we can't include the cantilever with the curved rafter as a single steel member. You can see that this steel member is made from multiple analysis members, and we are numbering the steel member to match the first analysis member in the list. This helps us to keep track of our steel member numbers. If the data in the remainder of the form is similar to the previously defined steel member, we can click the Use Previous button to fill it in, and then simply change the fields that are different. In this case, the flange restraints are different, and on the top flange, we have 4 purlins spaced 1 meter apart, followed by 8 purlins spaced 1.2 meters apart. Let's assume that both sets of purlins are providing lateral restraint, and so we must insert 2 L's in the restraint types field. Our curved rafter has 2 fly braces restraining the bottom flange, and we can define their locations and types in the bottom flange restraint fields. It is important to note that the restraint for a fly brace must be positioned at exactly the same location along the member as the restraint for the purlin or girt to which the fly brace is attached, otherwise it won't be fully effective. We can then click OK to exit and see the flange restraints visually. Before inputting the design data for the columns, we must first determine their top flanges, as this is not obvious for vertical members. This can be done by either displaying the local axes and noting that the top flange is on the positive local y-axis side, or by clicking the View Steel Member Top Flanges button. The small triangles touch and point towards the top flange. You can see that the left column has its top flange on the outside, whereas the right column has its top flange on the inside. Let's start with the left column. After clicking the Use Previous button, we need to change the load height position to center, as top flange loading does not apply to columns. We can then input the flange restraints for 3 girts on the outside, or top flange, which we assume provide lateral restraint to that flange. There are no restraints on the inside, or bottom flange. Let's now repeat the process for the right column, remembering that the outside flange with 4 girts is, in this case, the bottom flange. The inside flange is restrained with a fly brace located at 2.4 meters from the base and will be assumed to provide lateral restraint to that flange. Finally, we select the cantilever, starting with the member closest to the column. Let's assume that the free end of the cantilever is unbraced in the out-of-plane direction. For cantilevers, the restraints on the tension flange determine the bending effective length. This is different to non-cantilever members, in which the compression flange is the focus. Because space gas doesn't know that this member is a cantilever, we must specify the bending effective lengths manually. Finally, because the cantilever is assumed to be unbraced laterally at the free end, we will use a lateral restraint code of U for both flanges at that end. When we exit, you can see the flange restraints for the entire model. In the next video, we will perform a code check and design.